to. Yeah, here again. Thank you so much. I had forgotten about that. Yeah, here again for another opportunity to learn, and I hope that we are all prepared and ready to learn. Yeah. So, is Dixon on? Hello, Dixon. Hello, Dixon. Can somebody please confirm if you can hear me?
Yes, I can hear you.
Yeah, we can hear you for sure.
Okay. Okay. Thank you. Dixon, please, are you on?
Yes.
Okay. Okay. So without much ado, could you please introduce us to what we'll be doing today, and then I think we can move on from there into the program. Hopefully, I haven't missed anything.
Okay, so basically, I'm just going to pick a petroleum, like something petroleum, and then with what we've done already, without the ChatGPT model and everything, we'll just kind of merge it and see how we can apply it in a petroleum, something petroleum. So
Okay.
I wanted you guys to kind of give me anything, but then I didn't get, so I used my own stuff. So I'll be showing you that.
Okay. Okay. That's okay. All right. So I think because of time, you can carry on.
Okay, sure. And yes, share my screen. I think you should, I need access to share my screen.
Oh. So am I supposed to make you a host or something?
Anyways, I think you should just allow me to share. I'll just make screen sharing. I don't know how it looks like over there, but yes, if
Okay.
making
Fortune.
Hello.
Fortune.
Yes.
Yes. So you just allow, or you can make me the host. Let me sort that out.
Okay.
Hello, Dixon. You can share now.
So I'll, I'll make okay. I think we are all set. Okay. Can you see my screen?
Yes, I can see your screen.
All right, nice. Okay, so I think the other day, this is what we did. Let me start with the lecture over here. So we went through this slideshow. One minute. So we went through this. Can you see the presentation? Hello.
Yes, we can see it. Go ahead, Dixon.
Okay, so yeah, I can actually see. So we went through this. I mean, what the program is. I showed you examples of program languages, and specifically we focused on Python, a little bit about Python, data types, all the data types, everything. And then these are the keywords, and then this function, what an expression is, and then samples, iterating loops and everything, conditionals, all those things, classes. And then we tried this. The first day we did this. We tried the sample program the first day. And the second day we actually went to code. We implemented ChatGPT with this code. I kind of wrote it from the I ran you through the whole thought process on how you start something like this and how you finish it. The errors I made, everything you see it. So today you're going to do something very similar. So I'm going to take what we've done. So this is like a model, like you can see like a human being with all the world's information. And then I'm going to apply it to something specific in petroleum. And I choose the standard and cards. Standard and cards stats. I know if you're all familiar with this, but then it's some of us in petroleum engineering. There's this chart in petroleum called the standard and cards chart. That makes it easy to calculate the compressibility of a gas, compressibility factor of a gas, with just the pseudo reduced pressure and the pseudo reduced temperature. So however you find the pseudo reduced temperature and pressure, it's up to you. But then once you have the pseudo reduced pressure and the pseudo reduced temperature, you can actually calculate the compressibility factor. So I want to show you a little bit about what the sign and cast chart is what it looks like. So naturally or normally, this is how the chart looks like. Let me just do this one. This is how the chart looks like. So there's pseudo reduced pressure at the down, and then the curves. You can see on the line you have the pseudo reduced temperatures on the lines. So for example, if we have, let's say the pseudo reduced pressure is, let's say, 11, and then the pseudo reduced temperature is 1.4, just come trace from here, and then you get it from here, and then you get a compressibility factor for the gas. Okay, and then when you get that compressibility factor, that number means something. So I think what the compressibility factor is a dimensionless number that kind of shows us how the gas deviates from a real gas. Sorry, from an ideal gas. So we are dealing with real gases. So how does this gas deviate from an ideal gas? And then so if you have your compressibility factor to be 1, that means it doesn't deviate at all. That means it's that gas is an ideal gas. So I don't want to take you through that, but I just introducing you to what it is and then how we're going to apply. Our focus is really going to be on how we're going to apply what we built in the past to this. So naturally, that's if we are supposed to do something like this in class, we just calculate our compressibility factor. Sorry, calculate our pseudo reduced pressure and pseudo reduced temperature. However, there are different parameters you need to get those stuff. But then once you get them, you come here to this graph, trace your pseudo reduced pressure against your pseudo reduced temperature, the curves, and then you get a compressibility factor. You're going to use that AI model, and when you get a compressibility, you get 0.7. What does that 0.7 mean? When you get 0.6, what does it mean? When you get 0.25, what does it mean? When you get 1, what does it mean? So you're going to use the AI model we built to do something like this. So I've already, to save time, I already wrote down the formula for calculating the compressibility factor. And before that, I want to show you that formula. So this is from one of our lectures. I don't know if you see this, but if you're a kinesis and you remember this on the time. So this is Z. So there is a method. So you can actually use a graph. So the graph is more like a simplified approach to just trace your compressibilities and use them. The graph is more a simplified approach. But then if you want to, 1 minute. 1 minute. Okay. So 1 minute. Okay. So the graph is a simplified approach to do something like this. But then if you want, the graph came from a computation, a specific computation, and this is where the all right, so that's it. So So to calculate Z, you need all these things. So PPR is the pseudo reduced pressure, and then this is the reduced density. Come on. And then an exponent, then all this T, where is T on something? So T is the reciprocal of the reduced temperature. It's basically the reduced temperature, but then it's just an inverse of the reduced temperature. So everything is all the terms here are defined down there. So to calculate Z, you need the reduced, sorry, you need a reduced pressure, pseudo reduced pressure, sorry, and you need the reduced density. And I'll show you how to calculate the reduced density in no time. And then you need basically you just need the pseudo reduced temperature, but then there's an inverse of it, so that's it now. And so to actually get the reduced density, it's kind of complex, but then to actually get the reduced density. So like I said, we are going to use what we're going to do, we just need. Hello guys, I am so sorry. Hello. Can anyone hear me?
Yeah, Dixon, I can hear you. Please go ahead.
Yeah, let me share my screen again. Okay. So I have this, I have this, I have this. I'm trying to share my screen. Okay, so that's it. Okay, so back to where we are. I'm so sorry. So like I said, we only need two things: the pseudo reduced pressure and the pseudo reduced temperature to calculate the Z factor, the compressed Z factor. The same as the Z factor, or just Z, however you want it. And this is the formula we need to do this. So the graph you see over there, the underlying formula beneath that graph is this. So if you actually have to calculate Z, you need your pseudo reduced pressure, you need your reduced density, and then you need your pseudo reduced temperature. So like I said, we are only going to use reduced pressure and reduced pseudo reduced pressure and pseudo reduced temperature to calculate this. So this reduced density can be calculated with this formula. So if you see this carefully, I don't know if you realize, but then there's f of the function of reduced density equals to this, or this, and equals to 0. And how to get, so there's x1 over here, there's x2 over here, there's x2 over here. So this is a correlation, okay? All the Hubble, or Yabo method, it's a way of, it's a correlation. I'm pretty sure you're all familiar with correlations. I don't want us to go through the Patreon side, just see how the formulas and how we use Python and the code, the ChatGPT to do stuff like this. So this method, don't be scared. But then, in order for us to in order for us to find a solution to this method, we will use what we call numerical method. This numerical method, Newton-Raphson. I know something I'm probably all forgot. Then that won't be our main focus. But then we will implement a Newton-Raphson approach to solve this reduced density, just for this reduced density. So we have x1, we have x1 is a function of what? The reduced pressure. So the pseudo reduced pressure and the inverse of the pseudo reduced density. You see, x2, the same thing. That one's just a function of the pseudo reduced density. And then x3 is also a function of the pseudo reduced density. x4 is also a function of the pseudo reduced density. So once you have the pseudo reduced density, we can find the inverse and get the t. And then we can find x3, x4, x2, and for x1, 2, if you have a pseudo reduced pressure, you can still find it. And then when we find these x1s and x2s, x3s, and x4s, we fix them here and use the Newton-Raphson approach to solve this. So like I said, I've already written the code already. So let me show you, running through that very quickly. So before I start, let me run it through again. So to calculate V, we need the reduced pressure, and then the reduced density, and then the pseudo reduced temperature. This is the inverse of it. So coming back to the code, where is it? So coming back to the code, as you can see, where did I put it? See, so this is it. So this is, it's more of there are a lot of there are comments in there that can really help you. So I'll share everything. So don't worry about it. I'll share everything. So there are comments in there. So the formula I showed you in the picture, that's the same formula over here. But then this is in Python code. So if you can see x1, x2, x3, I think you can see the x's over here. So this way you calculate the x's just to get a reduced density. So first of all, I personally placed it in the function. You could do it any other way, but then putting them in the function is kind of cool. So you just call the function once with the parameters and you are done. So import NumPy. So NumPy and SymPy. So NumPy is a library. Before you do this, you need to, I'll do that for you to see. NumPy is a library that kind of helps you do easy computations in math. So there are some complex math you need to write in Python. And NumPy is more like, they call them modules. But in other languages, you hear something like libraries and all those things. More like a pre-written code already to help you make your work so easy. So NumPy is a module. But in other languages, they'll see something like a library. That kind of helps us. So we used it a lot. So anytime you see np or something, it means you're using from this module. And then SymPy is also symbolic Python. Same thing, similar to NumPy, but also kind of a different type, but then more like symbols, how to do some stuff very easy, more like how to do differentiation and all of those things. Because you have to differentiate for every iteration you have to differentiate. So this one helps with that one. And then our compressibility function, taking the PPR and then TPR. So the PPR is actually we're only using two things to calculate for the compressibility factor: the pseudo reduced pressure and the pseudo reduced temperature. So PPR and then TPR. And as you can see, I've written comments very well for you to understand. So calculate the compressibility factor using the Newton-Raphson method. Good. Then the parameters we are using what PPR, what is a fluid, and then what is the pseudo reduced pressure. TPR, which is a fluid. Remember the data types we discussed in your previous studies. A fluid, decimal point numbers in programming, they are called floating point numbers. So it's a fluid. And then pseudo reduced temperature. And then we have our constants as well. So I don't know if you remember 1 minute. I don't know if you remember how to use the Newton-Raphson. You need to kind of start with an initial guess. Like start with something. Oh my god. I'm coming. What is this thing? So I've been receiving calls and messages a lot, so I'm very sorry for that. And so I go off again. All right. Okay, so remember the T is 1 over TPR. Good. So this is the initial guess. Where is it? So the Newton-Raphson thing happens over here. The iteration. So that means we are doing 50 iteration. So we will need comment. We will need this over here. And if you can see TEA, very good. So break, I don't know if you remember, we break and continue. I used break on our previous code. In the Python chat code. Good. So you're done talking to ChatGPT. You remember that one. So when you're done, you press stop and then break. So break just breaks you out of the loop. Whether it's a while loop, this one is a while loop, and then this one is a for loop. Good. So the break just breaks you out of the loop and then quickly just it stops the loop from running. If you don't bring something like break, or if you don't bring condition for the thing to stop, your program will run forever. Okay. So back here. So you are calculating our x's. Remember these x's. This x is over here. So these x's. So these are just the formulas. So this x is over here. Calculating all of them. And then calculating the reduced density. So like I said, comments are here for you to be okay. Calculate reduced density out using the Newton-Raphson method. Okay, I think I'm coming. How do you input? So this is using the SymPy library. I don't know if you can see. Good. And this is just kind of it's actually attaching a symbol to RD. It's kind of irrelevant, but then and then the function using Raster, where is it? You can see this over here, this whole function over here. Good. So basically this I wouldn't want to go through. I just want to as to go to ChatGPT, take this code, see how the model will do what we want it to do. So I'm going to do that right away. If you don't get anything, please let me know. Okay. I want us to finish on earlier. So basically what this function does, what this Python code does, it's a Python function. So you can see that this function is one usage. What the one usage you see over here just means like we are calling the function we are calling the function once. It means we are only calling the function once. Yes. If I kind of comment this part out, comment in Python is like this. So if I kind of comment out, the usage is gone. All right. So if I kind of duplicate usage says 2, right? So just this is more of the work of the ID. The work of the ID trying to help you. Let me see. Someone said something in the chat. Yes, if you have questions, post them there. Great. All right. So this is more of the work of the ID. So if you are using a different ID, you might have a different experience. So I'm going to, so this code calculates compressibility factor based on two inputs, studio reduced temperature and studio reduced pressure. That's basically what I want you to know. If the high level value, this whole Python code helps you calculate the compressibility factor of a gas based on two inputs, the studio reduced temperature of that gas and then the studio reduced pressure of that gas. You don't need to worry about the reduced density and all those things. You just have to get your studio reduced pressure, get your studio reduced temperature, and then this program takes care of everything, and then it gives you your compressibility factor. So right now, when you get a compressibility factor like this is 4, like any number, any 0.2, 1.5, any compressibility factor, when you get that number, what does it mean? What does it tell you about that gas? So that's what we are going to make the model do. So when you run a program and then the program comes up with, let's say, my compressibility factor is 4, what does it mean? So we're going to build a program that will do that for you. So with this program, if let's say you have an assignment or you are doing something in class or an experiment in class, and you have this reduce we can actually go further and then get more parameters in order to calculate it. But then I started from just these two: studio reduced temperature and studio reduced pressure. So if you are doing anything in your class, doing experiment in the lab and everything, you have your studio reduced temperature of the gas, and the studio reduced pressure of the gas. You just provide this information and then the model calculates everything for you, and the model tells you some properties of the gas. Tells you, okay, based on this value, this gas is, let's say, it's comparing this gas is this gas is that, this gas at low temperature, this gas is that. So basically that's what we're going to do right now. So this code I already wrote, and this code. No. Yeah, and this code I think was supposed to be here. So this is what that I'm going to run it again so I see how it worked. The one we did for ChatGPT the other day. So I'm just going to run it. So run. It worked good. So hi. Taking a long time. Okay, let's just look. Okay, so it worked. So this is the code we wrote the other day. Having a conversation with ChatGPT. Hi, ChatGPT said hello. How can I assist you? So I want to use you. I want to use you. I want to use you. Thank you. Sorry. Sure, how can I assist you? So you can see it works, right? So we're going to use this model to do what we want it to do. So when we provide the two information, just the two information, just the studio reduced pressure and the studio reduced temperature, ChatGPT is supposed to tell us the properties of that gas. Like what is it? Is it anything? It's supposed to tell us what the gas is based on that compressibility factor we got. But then on a high level, anybody using the program doesn't really know what goes on under the hood. The only thing the person knows is I provide my two inputs, my CD reduced temperature and my CD reduced pressure, and then I get the properties of the gas. And like I said, you can actually modify this program by giving it more inputs. So you can go higher. You might know you might probably, because to actually get a CD reduced pressure and a CD reduced temperature, you might need some other things to even get. You need your critical pressure and all those things to get something like the CD reduced pressure. And the same for the temperature too. So you can actually go further or deeper inside and get some other parameters for this. But then I decided to take it from the CD reduced pressure and CD reduced temperature because that was just two inputs. And then we just use two inputs, make this AI model do wonderful things for you. So I'm going to do that right now. So we are just basically going to merge the two programs. So I'm just going to put them together. We're going to do some modifications and then see how we're going to do it. So this code we see here, this ChatGPT code we see here, takes an input from the user and then runs like processes it and it gives us some output and runs in a loop, a while loop. So while true means to run forever if you don't stop it. So right now it's still running, so I have to stop before it stops, before the program stops running. And then this code, what is it? This code also simple, also takes two inputs from the user, processes it and then gives us the output. So we're going to measure them carefully so that there won't be any conflicts. Measure them carefully. Conflicts are since there are different programs, like I said, this is a program that does, this is a program that does. We're going to merge them. So in case when you're measuring, one program doesn't stop one from running and all those things. So I'm going to do, I'm just going to create a new file right now for you to see. So I'm going to say, let me see. I don't know, let's see. So gas. I'll use the gas. Let's say just gas of 5. I think just gas. So we have this gas of 5. What I'm going to do first off. So so I'm running through my thought process right now here too. So we're writing this program, we are thinking. So the formal approach to doing stuff like this is you have to first write a pseudocode. What a pseudocode is more of just writing the code without thinking of the syntax, like whether you are right or wrong. So when you're writing the code, you're okay, do this, do that, do that. You don't really care about the syntax. You're just running through how you're going to do it. So this I'll call this function, I'll do this, I'll do that. That's like pseudocode. So in pseudocode, you can write in mere words, like mere bullet points, or you can write it in code itself. You don't have to worry about whether your program, like the syntax is right or wrong. So that's pseudocode. But then we are skipping that and we are just running through like my thought process. So I'm going to think on how I'm going to do this. So I've showed you guys on a higher level how we're going to what we want to do. And then we have things already laid down. So how we're going to merge this to kind of create a program we want. So first, first of all, like I said, we need a AI model to kind of do what we want. When we give the two inputs, the CD reduced pressure and the CD reduced temperature, we need the AI model to process it and give us the properties of the gas. Right? So good. So what should we do first? You have two different programs. So I'm thinking, since we need the AI model to process the Z, we need to calculate the Z first. So we need to first get the inputs on the user and then process it and get a Z. After we get the Z, we give the Z to the AI model and the AI model processes and give us our output. All in the same program, but they're very fast. Nobody will know something's happening in the back. So first I'm going to calculate the Z first. So to calculate the Z, this is what we have. Where is it? Z. So to calculate the Z, this is the code. So I'm copying everything and I'm bringing it over here. So I'm bringing it over here. Gas. So basically, this is what the function does. It's the same thing. So where do we get a Z? So this is where we get a Z. So the aim of the program is to take the two inputs. After taking the two inputs, we give the Z to the AI model. We tell the AI model to give us the properties of the gas, right? So when we come here to the ChatGPT, this is it. So this is what happens. So this is everything ChatGPT. Starts from here. We have this, we have that, and then it's very short because most of the thing is from the OpenAI library, but then they call it a module. So it's kind of very, very short. Along the line, if you don't get anything, please let me know. All right. Let me see. Okay. Okay. All right. So let's go. So there's this how do I do this? I'm going to arrange my code in a way that kind of makes sense, more like how everybody does it, so that when anybody takes your code, the person gets so confused. So anytime you're importing stuff, you need to import everything first before you actually start writing your code. So since I'm merging two code, you can see with this, I imported NumPy, I imported SymPy, and then with this, I imported OpenAI, right? So I'm going to import OpenAI as well over here, right? So I'm merging the code carefully. So no, Z, come on. So that one's gas. So I'm going to put OpenAI here carefully. Okay, since I'm not using it, that's been grayed out because I'm not using it. Then so now this is what I have to use it. Remember, I took to get the API key. I showed you. So go to the platform, the openai.com/API keys to get API key. Yeah. And if you have, if you're actually using, sorry if you don't get it, but if you have environment variables, if your program has the env file, you can just put your API key directly inside with the name OpenAI API key without doing anything, and everything will work. Everything is there, documentation kind of makes it easy. But we are not using any EMV file. Like I said, I wanted the code to stand alone. I wanted the program to stand alone and not depend on many other stuff. So we try to make it stand alone as possible. Even though we are still using NumPy and SymPy, and we are still, okay, so that's it. Mine gas. So yeah, so going to the gas, so that's it. Good. Oh no. Guys, let me close this. Oh no. If you look at the identity from this one, so compressibility, TPR, and to beautiful. And then we have this. Good. So I was supposed to paste this over here. I was supposed to paste this code over here. No, here. I was supposed to put it in the gas. I found this one.
We are trying as much as possible to pretend, but it's a little,
Yeah, don't worry. I'll show the code.
All right, all right.
If you need some serious if just let me know. I'll show the code with a lot of comments. I'll leave my email too. So sorry it's but no, when we are done, I'll run through again like bit by bit. So if you have questions, then right now I'm running through my process. I'm running through my thought process. So I might do something and go back and change it again because I'm kind of like I'm running like I'm improvising. So I might do something, change it again. I'll do something, change it again. So when we are done, the program works. I'm running through a bit. So basically, this is how programming is like some guy in glasses sitting somewhere typing very fast. It's kind of very slow and back and forth process. So, okay.
Yeah,
all right. Yeah. So basically, I'm like I said, I'm merging two codes. I'm merging the code for ChatGPT and then the one that I wrote to calculate the compressibility factor. So I'm trying to put them together and then make it do what we want. And I'm merging them carefully so that we don't have any conflicts. So okay, so going back to the gas. So this is it. So I've imported this. Like I said, now it is back because I'm using the OpenAI. So this is my API key. Like I said, you have to, if you want to get API key, go there, go to platform. You have to pay though, but then you won't pay initially. It's post-pay. So at the end of every month, they'll bill you, and it's not really expensive. And when you do, and then you don't want to pay at the end of the month, you can just disable your subscription before the month ends. Okay, let's go on. So basically, this everything works. We get ChatGPT. Sorry, we get our complexity factor. Then we come here again, code. Now this. So this message is that the message you have to send to OpenAI as part of it. So like I said the other time that when you are with this AI model stuff, there are three individuals in a specific conversation or three entities in a specific conversation. The first entity is the system. The system is basically you. You the one, the administrator, whoever is building the system. The second is the user, and then the third is the assistant. So I'm pretty sure the user and assistant, you revamp. The user is the person making the query. I want help with this. I want to do this, and the assistant is the one responding, basically ChatGPT. And then the system is you, the builder of the system, the builder of the software, the one building the system. So this specifically is the system. So basically, this is what we are going to do. We are going to tell the AI model something over here. So we are building a program. So your custom data goes to. So I'm going to take this one. The comments, the OpenAI hash, and then comments up and down there, they are not really necessary here. That's why I commented them. So you don't need them. Don't. I'll take you through everything when we're done. So I'm just running you through my thought process. That's all. So it should be confusing because I'm going back and forth thinking on this. I'm sorry. And that's how it is. Okay, so we have this. And then back to the code. Good. So when you come here, see what we implemented for ChatGPT for the first one is like a back and forth conversation. Back and forth. It is going back and forth forever till we decide to stop the conversation and say stop. Then the program stops. So you can use any condition you want to stop the program, but then we use the word stop. So if I say stop, then stop the program. Remember, so that's this condition right here. Conditional, just a simple block, 3 lines. If stop to go, then say stop. But what we want right now, remember, like I said, you just provide the 2 inputs, the model. You provide your fuel use pressure and you provide your fuel use temperature to the model, and then you get the properties of the gas. It is not back and forth. It's just like a one of something. If you want to do again, what do? You provide different inputs. You provide the reduce pressure again, zero reduce pressure again, and you provide you provide a zero reduce temperature again, and then you still get your output. So it is not like a back and forth something. It just once. So you provide this input, get your output. If you want to do again, run the program again, provide this input, get the output. Provide this input, get the output. So that is something you need to note here. That's a very big difference. So what is actually doing the back and forth conversation is this while loop. A loop and it goes back and forth, doesn't end. So this while loop, and we do not need a while loop, right? We do not need a while loop. So we just need to run once, not like run over and over and over and over again. So we have taken it of that. We're going to do this. I don't need this, so I'm not going to take it. So we need a user input. We need to ask the user for his input. And honestly, we are not supposed to ask the user for the input. Do you know why? Let me show you why. Because like I said, the users they are taking only 2 inputs from the user. We are taking only 2 things from the user, which is what the inputs, the reduced pressure, pseudo reduced pressure, and then the pseudo reduced temperature. We're only taking these 2 things from the user. And then when you come here, like I said, what we are feeding the model is the Z. We are not feeding the model, we don't have to tell the model anything, but we are feeding the model with this Z. We are giving this Z the model. We are giving the model this Z. Yeah. So I'll just kind of comment this on carefully here, and I'll put this here. So the input, let me just say, I won't say user input, I just say input. Model input. Model input is what Z. Let me just Python makes it so easy. You don't have to go and declare this variable first or do yourself anything. What's happening? So yeah, so the model input is the reason why it's grayed out because I'm not using it. That is why it's grayed out. So model Z. So if I just do this, the Z will also be grayed out. Now see. So what this means is that whatever we get for our Z, whatever number we get for our Z, I'm going to feed it to the model. And I'm calling model inputs. And then we make the model process it. So come back here. So when we feed our user inputs, we'll see where the user input even happen. So it's happening over here. So user message and then message that append the user message. And so honestly, I'm just going to take this one. This is a dictionary. So there's this one, come down here, come back here, and I'm just going to do this. Yes. And I'm going to call it model input. Remember, I call them model input. So I'm going to call them model input. I want you to pay by bit, so you'll be fine. Then have this user message. Also grayed out because we do not like you are not using it yet. Then come back to code, then message to append the user. So this append means like when we are doing a back and forth conversation, we add a previous conversation to a new conversation. So how this model works, the reason why ChatGPT can remember what you said in the past is because when the programmer was writing the program, he appended your previous messages. So it's not really anything like wow. It's actually wow, but it's not really anything wow. It just means whatever you've been doing, the system has been saving it. And anytime you do something new, it takes everything you've done in the past and adds your new ones to it and sends the model. So more like you ask hi, then the model said hello. Then you ask, I want to eat bangkun. Then the model said, okay, go to a restaurant. And then you ask which restaurant. So before you ask which restaurant, from the hi to the go to a restaurant has been stored. And then immediately before, like the programmer or the one building the model, before the one building the model sends the which restaurant you're asking, it appends like joining to the end. It appends everything you've done, bundles it in. It's usually called a JSON. JSON is more like how you transfer data back and forth by API calls. So bundles everything, and then sends the model. Then the model processes everything and brings your response back. So it's kind of wonderful because I remember what I said in the past and it's not. So basically, what we are going to do right now won't remember what we've done in the past because we don't need it. Like I said, it's a one-off something. It's not a back and forth conversation. So I won't take this. I won't take this line because we don't need it. It's just one-off. Provide me with your studio this pressure, studio this temperature, I'll give you the property of the gas. And then when you want to do again, just provide two different inputs again, and then we do. Unless we want to remember the property of the gas we did in the past, and then use it for something else. But then if you currently we don't, that's not what the aim of the program is. So we win this. We won't take that code. So this is where the magic happens. So this is what makes the API call like this is GPT-4 model. The last time I changed to GPT 3.5 and see how it worked. Basically this just so you can change the model GPT-3. You can change the model, but then 4 is kind of latest powerful model. So use GPT-4. I haven't had GPT-5 is out. So I'm copying this line. So we're just trying to merge code. Then create something wonderful. So after here, user message. As you can see, I'm in trouble. Let me see. Good message. Okay, so message append. Okay. So since user message is not here, I'm just going to do this. This message is going to be our message over here. I'm just going to say instead of I can just either change this to user message. I can just change this message. But let me just change it to message. Make it easy. Okay. Now it's fine now. Then results. So results is the results of the model. When the processing is done, when everything is done, the output how it looks like. So we're down is also here. Let's print as you can see it over here. But like the concatenation I told you is more like merging the ChatGPT with the like variables and strings like concatenation. So you know about that, and just take this line. I'm kind of pretty directly diving doing this. So I come here and results. I just go here. Okay. Look at my results. So now results has been the green out is gone. Am I here alone? I hope you are following. Yeah.
Yeah, we are following.
All right. Okay, so basically you have this. Let me see complexity. So I don't need this. Okay. So I'm going to run to the code bit by bit. So we start with import NumPy, we import SymPy, import OpenAI, and then we put in an API key, and then we do this, the rule. So do the system, the adding filter. What do you want the model to do? So let me actually add this. So what do you want the model to do? What do you want the model to do? So that's it. That one goes here. So I can say I'll provide you. So I can just say it's based on the V factor, or let me say based like that. So based on the compressibility, okay. Based on the compressibility factor, factor tell or tell me the virtue of the gas. Tell me the property of I'm using this a very, very simplified approach because the model has already been trained. So it's like GPT, generative pre-trained, emphasis on the pre-trained transformer. The transformer is the model architecture I spoke about the other day. But then it has been pre-trained already. So I don't have to like in a normal sense, if we are actually building this model from scratch, this is what we're supposed to do. We're supposed to give if z is equal to 1, what does it mean? If z means that z is a compatibility factor, okay. So if the compatibility factor is 1, what does it mean? If the compatibility factor is 0.5, what does it mean? If the compatibility factor is between 0 and 5, what does it mean? Then we provide all this information to the model, then we run. So I can actually do that right now because like it is already trained and I'm kind of training it again. So you can actually do that, but the model has been pre-trained already. So we really do not have to do that. I don't know if you guys can right. The model has been really. I'll show you. Let me just finish the simple approach and then you see how it works. So based on complexity factor, tell me the properties of the gas. Now, the constant data goes here. What do you want the model to do? This like the system, the administrator. Then let's get know what this does already. So this function, this is just a simplified. This is a simplified function to that out. Let me see message. Okay, a simplified function that coming. I think yeah. So it calculates the z factor, and message is going to go. Okay, I think I still need to append the message. Where is it? So I think I still need this. I need it. So come here. Message is append the message. So I need it. I'll show you why. I just realized it. So if this is message, let me just make this model input. This is message. Let me say model message. I don't user message. Let me just do user message. Okay. User message will be here. And then I'll do this. So message is happening. Okay. So it makes sense right now. So this is the user message. And then what basically I'm doing is I'm adding this this dictionary to this one, to this whole thing before I send it. So I'm adding this online 9. Okay, this message online now. I'm adding this to this line 54. Oh, really? I don't have 54 lines. Okay. Before I send it. So it is very needed. I'll add the append. Else the model wouldn't know it should do something compatibility. You can actually skip this. You can actually just skip line 9 and then you can skip it and then put all the content, whatever you want the model to do, put it in the user put it in the user prompt. You can a programmer, however you want it to be like. So when we're done, I tried both sides for it to see, but then you have to make it work first. Okay, so user message, row, content, all the inputs. Okay, then append. Okay, so basically I think we're done, and then we're going to run. If we fix errors, we fix them. No, we just move ahead. Okay, so the Z is the model input, right? So I'm going to do concatenation over here too. I'm just going to do something like this. You just use the double code. I'm just going to concatenate these two things. So the compressibility factor, the compressibility factor is the normal growth here. So I kind of brought something that is not needed. It's not like it's not needed, but as I may have so I can just remove all this and put the Z there directly. So I can remove this model input and then put a Z here. So I can just do this. And just do the Z. Then when I do this, I remove all this block. I make the code simple. See, it's still the same code, works fine, no errors. Just let me see how we can do, and then I before message. Okay, so this one's let me see. Example usage, you're done. So oh, that's okay, right. So I'm going to run this And then when it works, we clean the code. Then I'll run you through bit by bit very well how everything works. What to say, what to say, what to say. Now that's one. So I'm going to do samples. So first of all, it has code. So it's supposed to ask us of what is the reduced pressure. So pseudo reduced pressure, I'm so sorry. So let me see. 8.9. I don't know. This typing hours. 8. Oh no. So this is
Hello, Dixon.
Yeah.
Could you please wrap up within the next 10 minutes so that we can allow for questions and answers, and also to allow us to catch our breath after the first part?
Thank you so much. Also, there will be another session from right. There will be another part for me to continue.
Yes, you can continue from there.
Okay. So let me just say 8.9. 8.9. And the reduced temperature is 1.74. I don't know. I'm just type the numbers. And let's see. Oh my goodness, that was type message 917. Yeah. Only concatenate string, not numpy. Okay. Only concatenate strings. Okay, so I think we can I don't know in the next 10 minutes, right? Okay, so we now have to debug because they are saying on line 54 the user message row user content the compositor is this it says type error can only concatenate string, not numpy float. Okay. Somewhere. So what do we do? Guys, any ideas? We are
Well,
hello.
I think putting str in front of the z will work. What do you think?
Okay. More like making a string.
Yeah.
Like this. Okay, let's see. Okay. Let's see. Wait. So running it again. Guys, they said my Zoom quit unexpectedly. I don't know what happened. Hello.
Can you is it possible for you to reshare your screen?
Yeah, I can do that.
Okay, sure, do that.
Okay, so we have this, we have that, and then we have that. Okay. Yes, can you still see? Okay, come. All right. Can you still see my screen?
Yes, I can see your screen now.
Okay, so let's see 8.9, and let's see 1.74. If I think it worked, whoever gave me that solution, thank you so much.
You're welcome.
So you can see it's taking long because now it has to make an API call to OpenAI, process it, and come back. So it's kind of taking long, and it's good. Let me see. Okay, thank you. So ChatGPT came up with the composition factor Z of a gas, sometimes also called. Well, it's started giving us the whole thing like it's already pre-trained, so it has all this information already. So if you do blah blah blah, composition factor denotes how much. Okay, come on. So if V, okay, we know this. I mean the gas. So like in your case, where is it? So this was our Z. Before I'll output the Z so that we see the Z before. So the solution we're looking for is this. This is the solution you're looking for, but it kind of give us I won't say extra information, but then it kind of give us extra information. So after everything, calculating our Z was calculated to be this. Our Z was calculated to be this. And then yeah. See, so because this is what we're looking for, but then let me how to like prevent this extra information. Or do you think this just is like that? Because it's also good information. So basically, we were supposed to train our model ourselves, right? We're supposed to provide this with any extra information. If it's 0.5 means this, means that means that. But then since it was 0.9, it's almost ideal. Okay, they have been more ideal than real. So it's almost got to one, like almost one. So it's almost ideal. And then properties of an ideal gas. It's basically the properties of this gas. Yeah, this that. So our program works. We just have to optimize. We just have to make things nice. Like the edges are kind of rough, so you just have to smoothen the edges and make things good. Right, so yeah. So basically, you see it works now, right? So we just provide come with the compressibility factor. Sorry, come with the pseudo reduced pressure, pseudo reduced temperature, combine them, and get our Z. After the Z, we get the properties of the gas. So if you're in the petroleum lab somewhere, you need the properties of a specific gas. Just provide these two parameters to this program, and then you get properties. So like I said, you can actually go further. You can actually go further and get other parameters to calculate the acidity reduced pressure and acidity reduced temperature. But then using this is kind of cool. So we are not going to optimize. I think I was given 10 minutes. Out of
Yeah, 10, like 2 minutes.
2 minutes now, okay. So I don't want to continue, but this entire code again. So we successfully merged the two programs. So two programs, the one we wrote last time, and then the one I wrote separately. We've merged them together, and now we are kind of getting there what we want. But then we can fine tune it. We can, like I said, sharpen the edges and get what we specifically want. So that's you running through my thought process. So after the short break, we will fine tune things. We'll make sure the model doesn't behave like some way we don't want it to behave, and then we'll see what we can do. Right? Okay. So just 2 minutes now. Okay, now you can't see my face. So I just staring at the screen until 2 minutes. After 2 minutes. After 2. I think some of you joined I say late. So what we are trying to do is we are trying to where this standing and card. So this is the chart. You can see my screen, right? So I think there's someone here who just joined screen. So we are basically in petroleum. There's something like this. This is a standing and card chart, and it helps us approximate the compressibility factor of a gas based on two inputs, based on the pseudo critical pressure and the pseudo reduced pressure and the pseudo reduced temperature. So don't worry if you don't understand them, but they're just two parameters you can use to calculate the compressibility factor of the gas. And in normal classes, how we do it, we have our pseudo reduced pressure, we trace pseudo reduced pressure to the pseudo reduced temperature. So you see this 1.4 and 1.3. So you have your pseudo reduced pressure between is 1.35. It will somewhere here. You have to use your eyes and some imaginary lines to get it. So say our pseudo reduced temperature is 1.4 and our pseudo reduced pressure is 11. We trace 11 to the 1.4 pseudo reduced temperature line, and then we have a compressibility factor. So what the program we just wrote, what it does is after getting the compressibility factor, what does it mean? Fine, the compressibility factor of this gas is 0.2, it's 9, it's 1, it's what does it mean? Why that number? So basically that's what we are doing. So we are interpreting the kind of inferring on what type of gas it is, whether it's real gas or an ideal gas, trying to know what type of gas it is based on the compressibility factor. And we're also making a model calculate the compressibility factor for us very quickly. So you don't have to come to this graph and kind of strain your eyes and see some lines that don't exist and then get your G factor. So the model calculates the G factor for you very quickly and also interprets, like, gives you an idea of what type of gas and what gases is like the property of the gas based on the G factor. So basically that's what we just did on a high level. Bring two inputs, pseudo reduced pressure, pseudo reduced temperature, let the model calculate, give it to the model processes some stuff, and then gives you the properties of the gas. Yeah. So I'll welcome any questions if you don't understand something. This is Steve Petroleum. And
Thank you so much for
yeah,
it has really been interesting. Guys, so please, the floor is open. If you have any questions on all that he has said so far, feel free to ask. Well, whilst we are coming up with our questions, let me ask my question. I have two questions from what you did. So I would like to know, Dixon, please, can you hear me?
I can hear you very well.
Okay, so I'd like to know, is it possible for us to, directly give pseudocritical temperature and pressure, and then let's ChatGPT calculate the Z factor on its own without our function, and just calculate the compressibility factor, and then tell us what it says about the property of the gas. And then also, I would also like to understand, when you say that we are training the model, what exactly does it mean?
Okay. So the first question, yes, like absolutely yes. Like I said, the model has already been pre-trained. So it's a pre-trained model. So I don't know whenever we have a class, when you're building our own model from scratch, it's quite complex. Building our own model from scratch, we have to provide all the data. So the model is actually as powerful as the data you give it. So the actual code it's kind of complex, but not really complex. But what makes the model so wonderful is the data we give it, the data you provide. And actually, ChatGPT has been trained on like almost all the world's information, like all internet data. So it is very, very powerful. So what the code, there's someone somewhere in this world who probably wrote a function, a program somewhere to calculate the Z factor. And then ChatGPT was trained on that. So if you provide these two information like this to the pseudo reduce pressure, the pseudo reduce temperature to the model, it will do for you easy. Like it would. It's supposed to. It has to. Not tried it, but it has to.
Oh, okay.
Yeah. So, what would be what would be basically like inference? Like we are making infer on based on some outputs. So don't put your focus on the Sun and Cast chart. Put it on anything. Like we are just making a model infer. So let's say we came up with a Z factor like some other way, right? Or
Okay.
probably not Z factor, something else. But it's making a model infer. And this model has already been trained, it's already knows it. So we are not really stressing ourselves giving him information. But then in another case where the model is not trained and the training is just like if this do that, if that do this, if that do, like using the data to train a model, giving the model information, giving the model data, so the model is aware of what like, and not just aware, but then aware of how to navigate. Like I said, if this do that, if that do this, if this do that, it's kind of that's where the transformer model comes in. But don't worry yourself about that too much. It's
Okay. So the
yeah.
model, let's take ChatGPT specifically. When we train ChatGPT, are we training it to only act on, I don't know how to put, only act for us, or to have that general training? So if maybe, let's assume that calculating compressibility factor wasn't included in ChatGPT's already existing functions, and then I train ChatGPT to calculate Z factor based on the function that you used. Would ChatGPT only have that training for me, or it becomes a global something that anybody else will also be able to use?
Yeah, I get a question. So this is a question of this OpenAI should answer this, something like this. So it's up to them. If I was OpenAI and I was building something like this, every user prompt. You remember they told you they use your inputs to kind of further train the model. I don't know if you've seen something on that platform. They kind of use your data. Good. So with that, yes, they are doing it. So whatever the users are providing, they are kind of using that information to further train the model. Right? So the user asks this and the model comes up with this, and the user follows up with another prompt. They are kind of recording, not even kind of, they are recording everything. And based on what they've told us, they are using that set of like to train a model again. So yes, so they are okay, someone's hand is up. Okay, adults. Someone, okay, so someone. So they would have to do it. And if I were in their position, I would be doing that. So yes.
Okay.
But then it's not
The reason I
global.
was, it's
Just
not.
us. Yeah, it's just for us. But they can decide
Okay.
to they can decide to do it. And I think they are doing it because they'll be unwise not to do that.
Okay. So
Oh, yeah.
what if it's just for me, does that mean that anytime I use ChatGPT, it will still have my training, or is just for the session that I was using it for?
Okay. So I think it's you remember when I was doing I was like appending prompts, appending. Yes. So even if in a different conversation with your same session in a different conversation, that one will remember you the previous day. So if you say
Oh.
hi, hello, and then hi, hello, my name is Dixon, blah blah blah, I've done this, and then I start a new chat with the same model in the same session, it won't remember.
Okay.
So when you say hi, I think I did it the other wait, wait. Let me show you that. Wait. So on our the first thing we did, you can see this one, right? So message that append. So for every cycle, right, every see while true. So the code and if it will run over and over and over. So at every time we take our user input, so we take input, every we take user input, every so everything like back and forth for every round. So more like for every round of conversation, like every round of message you send, all your previous conversations are pending, and we send it all to the model. That's how the model interprets it. So in your API documentation, you can see it's structured as user assistant, user assistant, user assistant, user assistant, back and forth, back and forth, back and forth, back and forth like that, back and forth like that. So yes, it answers it.
Okay. Thank you very much.
Okay.
Guys, please, anybody wants to ask a question?
Hello. Can you hear me, please?
I can hear you.
Okay, good. So first of all, let me say thank you so much, Jackson. I'm really enjoying this session, and especially for me, who has a petroleum engineering background. Back in school, what you basically do is try to trace, and usually, at the base of the charts, things are not quite clear. You try tracing, and usually you won't get the actual Z factor. However, this is really great. I think its accuracy is also top notch. So thank you so much. Now, I have two questions. Sorry, I joined a little late, so you might have gone through this, but I would want to ask you again. The first thing is, on what condition does the Z converge, right? That's the first question. And the second question would be, what went into you predicting the first Z? Do you get that question? What was the thinking before you choose the first Z to use for the whole iteration?
Okay. Well, is this random guesses I'm coming? Let me show you that proof. Well, converge as it converge to what? Okay. Oh, yeah, I think I guess it. For the iterations, the back and forth, the nutrition part, right? Where is it?
Yes.
So the first you can guess anything, okay? You can set your initial guess to be however you want, okay? And I honestly don't know when it converged or not. There was this thing the code had. I don't trace, so I do 50 iterations, and I thought when I do 50 iterations, I'll get closer to the answer, right? So I don't see the 49th answer. I don't see the 48th answer. I chose not to. You could write something over here and then you see the numbers in the table from we can actually do it right now first. Right? But I don't see the 48th, 45th, the 30th answer. I don't see it. I only see the 50th. That's because that's what I want. And that's when this condition is met. I don't know if you are with me. Hello.
Yes, I get it.
I think there
Yeah,
are
I think
two
I
voices. There are two voices coming from the same.
No, that's Adolf.
Ah. I'm
The
coming.
other person is Fortune.
Ah, okay. I'm coming. So I can. Oh, sorry. This is the code I was showing you. Okay, this is the original code that was written. Okay, this is the original code, and I made ChatGPT restructure it for me. So you see this one, the inputs are here, and then they are inside the function, and this one it's outside the function. So it's the same code. I made ChatGPT restructure for me. So this is the original written code. Kind of messy, but then yeah. So I was supposed to use this one too. So ah. Oh my goodness. I didn't know she was from this one. Yeah. So yeah, who was asking the question and is there any other question? Hello. Hello.
Yeah, Adam.
So Dixon, great.
Yep.
I want to know for the condition you gave, which is EA is equal to, I'm not quite saying that clearly, but that condition, what makes you believe that within 50 iterations, that condition will be met?
Oh my goodness. I can't say any. I just thought I was using 10 iterations at first. Okay, I was using 10 iterations at first. We can actually do 100. We can need 1,000. But I just did it. Hello.
Oh,
We
okay,
can.
so that means we can do more.
Yeah. Oh, we
Can
can do
we
actually do 100 iterations.
actually print the EA at
Hello.
any?
Should we print it for each thing? Okay.
Yeah, so that we see
Okay,
that.
I'm coming. Let's do that. Let's do that.
Okay.
Yeah. Where is it? I'm fine. I think I'll just log code. Let me do this. Okay. Hold on. Okay. Let me use my original code because that's where I put it on. Simplify random ID input for XRD. Put it there. So print something like that. So XR. I'm coming. Ooh, okay. Let me run it and see. It's 0.5. 1.5. Okay. This F string thing, you confuse you sometimes. You know what the F string is? Hello.
Yeah, it's another form of concatenation, right?
Yeah, but it always confuses me. Like how you can easily concatenate functions and strings. Let me say function and strings. You drop your okay. Variables and strings at the same time. It kind of confuses me a lot. Let me see. This one's supposed to work. I think 1.4.
I think you wouldn't include the what is that? An exponent?
Yeah, I think it's a number of decimal points. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my goodness, help me out. 3, 2, 1. Yeah, let me stick that. I think. Okay. Now let's see. But then you can see, right?
Yes.
You can see. How many iterations is it? It's supposed to be 50. S range. I'm a little lightheaded right now. Come on. So 0.7. 0.6. Let me just take this F from somewhere and let me do my thing. So I'll just say thanks first and yeah. Guys. Okay. Oh my goodness. Can you identify the order for me? If you could, I just XR equals to okay, can only contain string of float here. Oh, alright. Guys, can you see?
Yes, please.
Yes, we can see. So I think in this case, EA is what 0. What's the final E?
0.9. It's like 0.012.
Okay. It still doesn't meet our condition.
Yeah.
Right.
Actually, so why does it break? Uh,
I'm guessing for the sake of this whole training, but whenever we are working on it, we can do as much iterations as we can, right?
Yep.
Yeah, because it might take time.
Yeah, this got like debugging. So debugging actually takes more time than I'm doing actual programs really. So
Okay. Thank you, Dixon. I get it.
Guys, please, any more questions? Okay, Dixon. So I think because of time, I think you can proceed.
yeah, so basically I'm done. So 0.1. Sometimes I'm actually shocked why one works. Why it works so fine. What that thinking? Okay, let's just proceed. So I'll share the code, okay? So when you run through the code and then you identify it, you can let me know, right? Okay. Hello.
Yeah, we can hear you.
Good. Wait a second. So basically we're done now. We're done. So when you got like so every so we could actually just skip all this thing. And you can actually do not to even bring a relative error. I don't know. Okay. Makes sense. Oh goodness. Who asked the question? Adolf.
Adolf. Yeah.
Okay. So see the error of these uh, okay, I won't spend much time on it. Let's just go on. But then I think the condition is met. I don't know how it's met, but the condition is being met. Because even if it's not met, it's supposed to do 50 iterations, but it's not met.
Could it be that it did 50 iterations and still didn't meet the condition?
If it did 50 iterations, this was supposed to be 50. This was supposed to run 50 times. Like all this, it was supposed to run 50 times. And what I'm seeing here is not up to 50. I don't know. One,
Can
two,
we count our iteration,
yeah,
like
let's count.
the
Let's count.
counter in our code? Yeah.
Let's count. So let me put the count here. Yeah, I'm sorry. I just I have to put the items out. I'm supposed to leave for the queue. So count supposed to get there. Then I'll just come here. Let me just put it here. Count equals to count. Okay, then I'll just count. Right. Then we run this. Oh goodness. 1.3, 1.3, 1.4. Did you see something? I mistakenly typed this character and then it rejected it. So you can actually do a program in a way that if this character is there, can throw it away or something. But that's another time. Let's focus on this. 1.4, 1.5. We did only 11 times. Did you see? Hello?
Yeah, I saw it. 11.
We only ran 11 times.
But
And the
it
actual
looks
thing
like the
we ran,
condition wasn't met.
the condition still wasn't, I'm sorry. Oh, okay, it's a complex number. Oh my goodness. The inputs. Okay, so more like the results of the I mean because of my input, it's a complex number. So we are supposed to extract the real part. We're supposed to extract the real part of the number and then throw the complex part out.
Oh,
Because you remember it is telling us we've given it a complex number and includes the real and imaginary parts. So the actual study of the gas, so we are supposed to extract the real parts. I don't know if that makes sense though. So there's a slight error with this code. Not error, but there are some things we didn't take care of. So I just realized we can actually get complex number as our answer. And we need to do something else in this. All the time. Wow. Almost every day when I'm doing this, I'm actually thinking the time's not enough. Sorry, the time's too much. But then when actually doing it, you realize the time's not enough. So, Adolf, you asked the question, right? That's a very good question. That's actually,
yeah.
So this condition is still not met, but the thing is working fine. Or it's because they got a complex number, it had to like stop. I don't know. Or maybe because it's complex, it is when it's comparing. Oh, I don't know.
Yeah.
Uh,
I think that would be the issue too.
Yeah.
You can't
Yeah.
compare it with the condition you gave.
Yeah. Probably.
But I think that is for us to find out when we are playing around with the code after the training.
Sure.
Yeah.
Sure. So any issues have the code, let me know. Okay, I'm very interested. When you're playing around the code, anything you find, let me know so that we can make it better. Right. Okay. So basically, we do this, we do that, we import NumPy, SymPy. You actually, because we're using SymPy, that's why. Uh, Honestly, I wouldn't really want to use it, but it makes it easy. Because I don't want the code to depend on other stuff. So before you actually use this code, this will have to be. Let me show you. This is terminal. Let me see. I just pip install. So let me just say, we have to do pip install NumPy. Then you install NumPy. I've already done it, so I think nothing will happen. Then you have to also do pip install SymPy. I've already done that already, so nothing happened. And you also do pip install OpenAI. That one too. So because you're all using modules from all this. So you have to do that. Okay. So now your program is dependent on these three stuff. So if you just take this file, if you just take the code and then start running, it won't run. You have to do use a Python installer package to install all these modules first before it works fine for you. Okay. So again, we're importing our dependencies, and then like I said, this I'm including my API key. Actually, I'm not supposed to do this. You're supposed to just go to your .env file and put your API key there, and then the program OpenAI itself will find it. The env means environment variables. Environment variables are like API keys, like sensitive information that you don't want other like usually when doing this development stuff, you push the GitHub back and forth, and collaborate with other people. And sometimes API keys, not just API keys, some secret passwords and all these things, or some stuff that you need in your program, but you don't want to share with other programmers. You can keep them in your .env file. So when you're pushing, Git automatically knows that you have to leave the .env file, so they'll put it elsewhere. And then they'll push your code. Your code will go, and then your sensitive information and everything will still remain. So this practice is not good. It's not good. I'm supposed to put it in the EME file, but I don't want us to depend on that stuff. So that's what I'm doing this way. And then yeah, so this is a function. So it's a function. So I put everything in a function. Like I said, this is the original code I wrote. So this is a function, but then we make ChatGPT restructure everything for us. Okay, so that's it. So you can make ChatGPT restructure the code. But probably I can go and paste this and I'll ask it. The condition is not met, but then the code is still running fine. So why? And let me even point this out. This script, this thing works fine. It works fine, and it remembers this message. And the other day when after the lesson, I sat down and I realized why is it working? Because I do not when ChatGPT comes up with this response, I don't keep it. So why does it still remember? Then I realized this message is the same as this message, right? So is it if it's working, don't touch it, right? When it was working, I didn't touch it. If I probably had changed this, made this a different variable name or something, it probably wouldn't have worked. So this append message only appends the user message, doesn't append the assistant message. But then it remembers the assistant message as well. So I was like, oh wow. So probably if I had used a different name or something, it wouldn't have worked. So when you're playing around with it, try and change this the names over here. Make this a different variable name and see something. Right. You see it's not working. So that means you have to also come and do some append over here before you even print the message. Just come here. Okay. Just come here, then append as some message or some append as some message. And it'll work fine if the variable names are different. Because we're only appending the user, but also it's a user assistant, user assistant, user assistant, user. So you have to append all of them, like that whole conversation, and then add it to your new prompt and send it. But we don't do that. So you have to do something like that. Okay. Back to the code. So that yes. So we have to figure this one out and calculate actually the formula. So I'll add this to it. I'll add this is a formula, it's okay. So I'll add this. They're just two images. I'll add them to the files up there, and then you can see them. So you can actually run through and write the formula yourself. It will be pretty hard to write it yourself in Python without the NumPy and SymPy. So you should import them and use them. Okay. I'll be here. And yeah, so this is the formula and everything. Then this is the part. So I see this Z, you can see I start calculating everything. You bring it in the final Z. Where is it? This one. This one. And then yeah. So whatever Z we get, we give it to the model. We give it to the model as a user prompt, right? In a user the OpenAI, and that's why I'm doing like this because that's how OpenAI said we should send them the prompt. So you can also we could have just a user message equal to Z or Z. But OpenAI, when you read the documentation, this is how do you understand it. So you need to structure a prompt like this. If you want them to process it very well, you need to structure a prompt like this. So that is what I did. And yeah, so we appended the message because I wanted to add this message over in online 9 to this one. To this one. So we can actually skip it. We can just do this. So the complete factor is this. Give me the probability of the gas. You can just do this. You can just apply this. Give me the probability of the gas. Tell me the probability of the gas. Can you see this, right? And then we do this. And see, message, append message, append message. And then do something like this. And then instead of we just say your message. We are underscore message. Right? We can just see this. And then we come here and then hide like this. Whether we hide it or not, we are still not using it. Then we run. So when we run, I think it's supposed to work fine. And then just see 1.7. 121 times. Oh my goodness, that was again. Oh, fuck. Why are we getting it all of a sudden? OpenAI bad request, okay. So probably not my fault, okay. Let me try the first prompt I tried. I used one, let me see, 8.9, 1.7. Not again, no, not again, not again. Let me just think back to my thing, So like I say, with this, you have to just carefully sit down, review the code. So at this point, the code works. But then there are some like issues you need to fix and all this. So this actually not needed right now. Just, and I'll just say yeah, design message, and then this one is a message. Okay. Yeah, she's from there. Okay. So this message is from their response. Okay, this message is not the same as this message. This message is from it's from it's a result of the API call. So you made the API request and then they give you some outputs. So this model is the output of that. Okay, all right. Thank you. This one, okay. $19. Oh my goodness, this work. Thanks. Okay, wait. Okay, so so we had this video of a computer factor for this one, and it's saying that's more compressible, blah blah blah, giving us all the properties we want. Okay, so this one worked. All right. Okay, so if you guys actually do, if you take this and then you build on it, you do some changes, you modify it. So basically, this open source code, okay, huh? So whatever you do with the code, your improvements, your changes, any bugs, anything I did but I didn't do well or that could be done well, you can let me know and then actually share it again. I'll probably put that one as a default. Okay. Okay. Hello.
Yeah, we can hear you.
All right, sure. Okay. Yeah. So basically, that's it. That's it. So if you want to specify that, you make the model give you just the properties, not talk plenty. One is more of prompt engineering, not really coding. You just have to see, instead of trying error, you try this prompt very carefully, see the output, try this prompt again, see the output, try this prompt again, see the output, and then know how to structure a prompt, know how to see how you get what you want from the model. Probably you didn't want to talk. Hello. Oh, okay. I think, yeah, I'm here.
Is just what you just did, is it what you were calling the fine tuning the output?
Okay, which one?
Can you hear me?
I can hear you very well.
So I was saying what you just did with changing the output and stuff, is that what we are calling the fine tuning the output or the other things to it? Because I remember you said you're going to fine tune your output to make
Yeah,
it more presentable and
yeah, but it looks like I didn't. So that wasn't what I was doing. So I think the error kind of like seeing the error. I didn't see the error before this, so kind of seeing it again. It made my mind a little like kind of
I get
turbulence in my head. So we didn't do that. So that one, I mean, see down here. Down here we have so much like unneeded information. Like it's not even defining what complexity factor is. Well, is that it? We only want the properties of the gas. So we have to like, oh, and also the fine thing is restructure the code, making sure like it's neat. Like I don't know if you get kind of is it messy? For me, I can see what I wrote about. Probably if
yeah,
we are
without the
not a
comments, I
comment,
think
but I'll put comments inside. I'll put more comments inside and then before I upload, I'll put more comments inside. So that was part of it. But then what I really wanted to do was all this. I don't say useless information, but extra information we don't need. We only need this. We only need this. So in this case, like from here, in this case where the composition factor is this, it implies that the gas is just the property of the gas based on the composition factor. So just that. Don't define anything, just that. And that one is more of prompt engineering, like I said. So I'm coming. Based on something like that, tell me the properties of the gas. Tell me only. Let me see. Only the properties of the gas. Okay, now, the gas alone. The gas alone. Nothing else. In caps. So I'm trying to modify this one to see what happened. So now let's see. So that's 8.91%. So about the complex parts, I would be glad if any of you figures it out. See how you can extract the real part from it, and then leave the imaginary part. Let me just remove this one. So the community factor is for our gas. The community factor is just suggests that the gas. Well, we kind of got closer to it, right? I don't know if you see.
yeah.
We can even give it examples. Let's see. Let me use this as an example. So, let me see. So I'm kind of so. So examples are like in the prompts, and it's still prompt engineering. So examples are you putting examples here. So based on the competitive factor, tell me the pressure of the gas alone, nothing else. So I just see examples and just put here examples. Right. Some models allow you to give examples in a separate like in a separate variable. Something like Google Bard Palm 2. When you're doing your Palm 2, they allow you to give examples in a different, like, see this one, we are doing it inside the system prompt. So basically, we just want to tell the model something, and however you want to tell it, it's up to you. But using a system prompt kind of gives it more priority. So you can do this in the same user prompt, but in a hidden user prompt. But then it carries less weight. So for Google Bard, they provide a separate stuff, separate, is it called context or something? I think it's the variable name is context, and then you give all the context you want to your model and put it inside and you send it. So as examples, let me see. Compressibility factor equals to 1. Properties. When this equals to, and just check. Oh, so let me just use this. Someone asked this question some other time. The double quote and then the single quote. So if I'm using double quote to do my string, I can use single quotes inside. Same way, if I'm using single quotes outside my string, I can use double quotes inside and it'll be fine. Otherwise, I have to use that the escape element. But then there's this escape. But then I can go like this. So properties. So I do guys. So the properties goes here. Let me see the properties. Goes here. Wait, let's do. So what I'm expecting with what I've done, what I'm expecting is the model should structure the response in this way. So let's see. 8.9%. So let's see. I think it did, right? Did you see? Hello. So
Yeah,
it gave me just the properties. Just the properties, nothing else.
Yeah,
No,
it's
but
shorter.
yes, it's short. So kind of what we want. And with this is exactly what we want. Only this. With this, I can predict that anytime we use this specific prompts with this example, we can get our prompts in this way. So if you are using your program, you can just say, well, because I think this one always exists. Well, if you're writing a program and you get, you want only this part, you can use this to get it. Because you're looking at how it should always appear. Let me try it out. So 8.9%. 9. Oh no, sorry. Let me write it again. I think this is 7.9. 7.9. 1.4. So what I'm doing is just prompt engineering. It's not really cool. It's just manipulating your prompts like to to get what you want from the user. Okay, so this is what I didn't do. But just give me the output. See, at least we are getting closer to it. Oh yeah. So we can I think uh we can still modify it from giving more examples and force it to like come up with how we want it to be like every time. So basically, this is the ideal thing one. This is what I wanted from the beginning. When it comes, just give me the properties based on whatever we give you. Just give me the properties. So the gas is behaving non-ideally, and it is more compressible than an ideal gas under the same conditions. This may be due to blah 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 blah, giving you the pressure of the gas. Just that, nothing else. Yeah, so we can be playing around with it, trying, modifying, just doing stuff. I mean, I would love to hear what you guys come up with. I can add more stuff. Can I don't know anything. It's not possibilities are endless. They're really endless. And yeah, so I think one session, you should also learn how to create your own model from scratch. Not like a very big model like ChatGPT, but a specific model doing something so specific. So if we're supposed to do this ourselves, we're supposed to provide the data ourselves. We're supposed to run through all the possible values of the z factor, and then provide properties against all the possible values. So if the z factor is 1, property here. Z factor is 1.5, property here. Z factor is 2, property here. Z factor between this and this, property here. Then with this data, more like a key value pairs, we train the model, we give the model the information, and it's just more like a, I don't know if you remember this regression. It's a regression analysis, trying to then correlations, trying to find a line of best fit. Right, you have so much data, and then you try and fit the line. If you remember how to do something like that, you try and fit the line. So once you get a line of best fit, anytime you want to predict the other one with that input, you just bring an input and you use the line of best fit to predict the other values, and you kind of get it closer to it. And then the closer you get to the answer, it's mainly dependent on the data you had in the beginning. So let's say you had 3 data points and you're trying to predict the next one. It's kind of, you won't really get the answer if you had 10 data points and you're use 10 data points to predict something else. I think I'm making sense, but basically that's how it is. But it's more on a very large scale with very large GPUs doing this pattern. So yeah, today was hectic. Very. It's almost 5. I did all this well. Out of
It's been educative as well. Watching.
Yeah, Dixon, thank you so much for the time and all that you've shown to us. Personally, I've enjoyed today's session and I've learned so much. It's like for me, I'm one AI enthusiast, so like seeing more of these things is really inspiring. And also, thank you so much for the explanations, taking us through all of these things. It kind of helps us to appreciate AI more and more. We are really, really grateful for your time. I mean, the resource and everything that went into all of this. We are so grateful. Thank you so much, Dixon. And personally, I know that I've left. I'm leaving this program and this year, for that matter, with something new and something big. And that's all thanks to you. Thank you so much, Dixon. We really appreciate it. Does anybody want to and maybe any questions or anything you want to say to Dixon before we wrap this session up? Hello.
Yeah, fortunately, I would also want to thank him so much. Just from the first day, the basics he taught us. The second day, how we applied the basics we learned, and then today, being able to do our own projects. This has been amazing. I've learned a lot as well, and there's more to learn. I believe what I've gained here will actually help me next time I'm doing anything of this sort. If I want to pursue anything in AI, I know the fundamentals I've gained here will really do help me. So Dixon, thank you so much for your time, your efforts, and all that you've put into this. We are really grateful.
thank you. Yeah. Thank you for the opportunity as well. All right.
Okay. Samuel wants to say something. Samuel, please come in.
Thank you. I would want to toe the line of the already expressed gratitude to Dixon Ajay for being able to not just express what AI stands, but to do it stands for, but to do it in a manner that almost everybody, or if not everybody that's joined in, has been able to have that great understanding, as Adolf said, from the foundational level up onto the point of application, particularly in the energy industry, specifically in the oil and gas industry. It's really amazing to see this dedication and selfless act, and as you've done. And on a personal note, it's something I've learned from this, to be able to apply AI in my fields of endeavor, and to probably see how I could develop models, as you've tasked us to do in our various fields of endeavor, to ensure that we're also able to help people out, people able to use our models to also make life easier and better for people. Thank you very much, Dixon. And also thank you to the team that's worked on this, Adolf, I know Fortunes helped out. I know Samuel was in at a point, and all their team that's helped ensure that this was a success. Thank you very much for putting this together and helping people such as my good self to benefit from this.
Yeah, thank you very much, Samuel. Rosemary says, thank you. The sessions has been insightful. I've learned a lot. Good to hear that. Osei says, thank you. Thank you very much, Engineer Dixon. Yeah, so thank you so much, Dixon. Yeah, we really appreciate the time and efforts that you put into all of this. Yeah. Any more questions, guys, before we wrap up? Anything else anybody wants to say?
I would just like to remind us again that although the session for this month has ended, we have another session next month, and that promises to be more interactive, educative as well. So over the week, you will see our flyers. Kindly do what to share with your colleagues, people on your contact list, and let's make it fun like we made this fun as well. So all the best to everyone. Thank you.
Thank you very much, Adolf. So we're in the absence of any further questions, then I believe the meeting has come to an end. Yeah. All right, so bye, guys.
Bye. Merry Christmas to everyone.
Oh yeah, Merry Christmas.